Hi everybody, in this video I want to just introduce the basics of square roots so that we'll be able to use them in later sections if we need them. Now this may be a review for you, so if you're pretty comfortable with square roots, then that'll be great. Hopefully this will be really quick, but if you haven't seen them in a while, it's a good chance just to kind of review that notation and how to find our answers. Okay, so first, couple definitions. So we've seen squares already. So the square of a number is a number times itself. So for instance, if I have something like 4 squared, that means I take the number 4 and I multiply it by itself to get 16. Or if I have negative 3 squared, again, I multiply it by itself. That exponent of a 2 tells us how many times to do it. So I have positive 9 in this case. Ready? So that idea of squaring is that exponent of 2, remember. Okay, so we know what squares are. And the reverse process of this is finding a square root. So the opposite idea is to find the square root. So for example, let me use these two examples here. A square root of 16 is 4, for instance. And what we do is we write this as square root of 16 equals 4. Now, one thing to note here, which gets a little bit tricky, is that there actually are technically 2 square roots of 16. So another square root of 16 is negative 4. And that's because negative 4 times negative 4 is also 16. However, I will tell you that the positive version is called the principal square root, and that is typically the one that we are given. So and we have the example here too with a negative, right? So negative 3 times negative 3 is 9. So is 3 times 3. So maybe I should write both of these examples down. Four. So technically there are 2 square roots for each number because you could have the positive value being squared or the negative value being squared. But I will say that when we're talking about square roots and you're looking for an answer, it is typically the positive answer that is given. That is what we call the principal square root. So it's just something to watch out for. That yes, technically we do have 2, but when we're looking for the answer, it's the positive answer that we're given here. Okay. So this symbol here is called a radical sign, or a square root symbol. You will hear as we go through class and you get into higher level mathematics, usually we'll just say the radical or the root sign. We tend to use the words radical and root interchangeably. They really do represent the same thing in this case. And like I said before, when we're giving an answer, we typically give the positive answer. The only time we would give a negative answer is if the negative was in front. So let's look at some examples. So if I want to find a square root, you're basically saying, well, what number, when you square it, is equal to 25? So that's what you're asking yourself. So what number when we square is 25? Well, the answer is 5, right? Because 5 times 5 is 25. So the square root of 25 is 5. If I asked you about the negative square root of 25, well, then you could write negative 5. So again, that root typically refers to the positive answer. If we're looking for a negative answer, we would add that negative sign out front. So your root symbol, you want to think of as the positive answer here. I guess I should call this B, huh? How about the square root of 36? So again, you're saying to yourself, what number, when it's squared, is 36? Well, the answer there would be 6, because 6 times 6 is 36. For the square root of 1, the answer here is just 1, because 1 squared also equals 1. And then the square root of 0 is just 0, because 0 squared does actually equal 0 as well. We can also apply this to fractions. So if I want to do the square root of 4 over 25, so the square root of 4 is 2, and the square root of 25 is 5. So if I think about this, 2/5 squared would be 4 over 25. So I can also apply the same idea to fractions as well. One thing I do want to note is something like the square root of negative 25 is not a real number, okay? So when the negative is inside a square root, the result is not real. It's actually called an imaginary number, which we're not going to see in this class, but you'll see in other classes. So it's not real. So you do want to be careful. And that's because if you think about it, you would ask yourself, well, what number squared equals negative 25? And no real number works, right? If I do 5 squared, that's positive 25. If I do negative 5 squared, it's still positive 25, because negative 5 times negative 5 is still a positive. So I just want to make a little note here that a negative on the outside is fine, because it can basically just come and get attached to your final answer. But a negative inside the root it can't happen for real numbers. Like I said, in more advanced classes, we do actually talk about imaginary numbers. It's kind of a poor name, because imaginary numbers actually have a lot of real applications. Satellites is one of them. Also, electricity is another. So it's, again, like I said, it's kind of a poor name, but they do actually have a lot of real applications, which hopefully you'll get to see in a later math class, depending on the route that you go. So here are how we can simplify these roots. So I do want to ask the question, how do we simplify if the root doesn't come out even? So for example, and there's sort of two ways that you can do this. One is you can use a decimal approximation, i.e. use your calculator. Now you can do decimal approximations by hand, but it's sort of a guess and check system where you try to get close to it and then you multiply the numbers out to see if you get close. It's really not the best way. So you can just use your calculator to get an approximation here. So for instance, let's say I have something like the square root of 50. right? Now, if I think about it, there is no number such that the number times itself is 50. If you try to think about it, it doesn't work, right? So one thing you can do as a little side note here that you may find helpful is to just kind of list out some of your squares. So for instance, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. And again, I could keep going as far as I want to. I would say numbers 1 through 10 or maybe 1 through 15 are probably good just to kind of have on hand. So if I look at 50, I see that, there is no 50 here, right? It's not a perfect square. So when we say perfect square, it means it comes out perfectly even, right? Like if I took the square root of any of these numbers, then I would get the answer on the left side without the square sign. So this is not a perfect square. So what we can do is we can use our calculator. So this is a more advanced calculator that I'm using. It is an app called Calc 83 for the iPhone, and it mimics a TI 83 or 84 calculator. So if you have one of these, I'll show you how to use it, but you can also use just a standard calculator. So on one of these, you'll see right here, there's an X squared key, and in yellow, you have this little tiny square root symbol. So to use those little yellow symbols here, I have to press the second key. So I press second, and then I hit that X squared, so that square root button, and you'll see that it comes up here. And then I can type in 50 and hit enter. And it will give me an approximation. So I'm just going to round this to 2 decimal places. So it's going to be about 7.07. So about 7 7/700, right? So I'm just using my calculator as an example here. Okay, now I want to just find you a more standard calculator. Second. All right, so here's the calculator that came with my iPhone. Obviously, this one does not have any root keys on it, so this one isn't going to help you. But if you turn it to the side, I have to maybe hang on, let me pick it up to do it. Sorry, I had to hold it up in the air. If I turn it to the side, it actually expands and gives me a much nicer, more advanced calculator. And you will see a square root key right there. So when we don't put a little number in, there is always a 2 on a square root key, or 2 for a square root. So as a little side note here, make this on my lecture notes for a second. The square root is the same thing as this. We don't put in the little 2 because we do square roots so often that we tend to drop it. But that's the same thing here. So I can go ahead and use my calculator in this case and type it in. Now this one works a little bit backwards, so you just want to be careful. You don't do the square root first and then the number. I guess you can actually do it both ways. So I guess we can do the square root first and then the number, but hit enter or hit equals. Or if you do it the other way, hit the number first and then you hit the square root symbol, it will just do it for you. So kind of play around with the calculator a little bit. Make sure you know how to do square roots on your calculator to get these values. So let me do the 51. So I'm going to do 50, hit the square root key, and again, there's that same approximation. And there's lots of free calculators on your apps or even on the websites as well. Just if you just search for a free scientific calculator, you can get one there too. So don't go out and spend a lot of money on this. You probably have one on your phone already, or if not, you can find one online for free. Okay. So the first thing is, again, like I said, we can do approximations by hand, but they're quite tedious. And I think at this point, we should just use our calculator. But the second thing you can do is you can simplify a bit. So I'm going to use my same example here. And I'm going to show you a little trick here for simplifying these roots. It's not going to be perfect, but it's going to be better. So what you try to do is you factor such that one of your factors is a perfect square. And you want to find the highest perfect square you can, okay, ideally. So if I notice for 50, 50 is the same thing as 25 times 2, right? And 25 is a perfect square. So what I can do is I can take that square root of 50 and I can rewrite it as the square root of 25 times the square root of 2. And we'll talk more about these kinds of rules towards the end of class. There's a lot of rules that we can do with exponents and things like that that allow us to manipulate like this. But this is one rule that I just want to show you now. So you can split your factors. You can't do it with addition or subtraction, but you can split with multiplication and division. And then now you can simplify here. 25 is 5. This becomes 5 times root 2, and we usually just write it as 5 root 2. So that is a way that you can simplify a little bit for your fraction. And you'll do this a lot more in advanced classes. So let's do one more example. So let's do the square root of 18. And again, if I go back to my squares list here, 18 is not on there, so it's not going to come out even. So I'm going to have to approximate it. So let's use our calculator first. So going back to that scientific calculator on my phone, I'm going to just hit the 18 and then take that square root key, and I get about 4.24. Or again, if I have a more advanced calculator, for those of you who may have it from high school or something like that, then what we're going to see on the TI 83 or 84 series is you'll see it about right here. So I hit second and then the root first and then 18. So when you do it on this calculator, you have to do the root first. And then I hit enter and I get the same result there. Now, what we can do is we see if we can break this down. So if I think about my factors for 18, it's 1 times 18, it's 2 times 9, it's 3 times 6. And I do see that I have a perfect square right here. And that's the best one I have, right? So I always want to choose the best one. So what I can do is I can take this 18 and I can break it down into root 9 times root 2. I tend to like to write the square first, it just makes it easier. And then this root 9 is 3, so this becomes 3 times root 2, or 3 root 2. So just a little precursor to kind of where you're going to be going with simplifying roots. So if they don't come out even, then either we can use our calculator to get an approximation, or sometimes we still may want the exact form, but we can simplify it. Now, not every example can be simplified. So let's say I have the square root of 15. That's not a perfect square. If I think about my factors, I have 1 times 15, and I have 3 times 5. There are no perfect squares here, so I cannot do this. It's only if you have perfect squares that you can go ahead and do this. So I can't actually write this any better, but I can, of course, get a decimal approximation if I want to. Let's see, where did my calculator go? So it's about 3.87. And finally, there are other roots. So for instance, we have a cube root. We use this symbol. We have a fourth root, this symbol, etc. Fifth root, a sixth root, a seventh root. You can do as much as you want to here. And so what you're looking for here for your answers, for instance, is a number such that when you cube it, you get the results. So let's say I want the cube root of a. Well, I'm looking for the number. When I cube it, I get an a. Or if I want the cube root with here, it has a 4, then I'm looking for the fourth instead. So I'm not going to go again into a ton of detail here because you're going to see this later in more advanced classes as well. But this little 3 or 4 here is actually called your index of that root. And if it's a square root, we don't write it in. So like I showed you previously, if there's a little 2 there, that's fine, but we typically don't write it in because our square roots are the most common. So for example here, the cubed root of 8 is 2 because 2 cubed equals 8. 2 times 2 is 4, times 2 again is 8, for instance. Or the fourth root of 16 is also 2 because 2 to the fourth is equal to 16. 2 times 2 times 2 times 2 will give you 16. So you're doing the same process there as you would for square roots, but it is more challenging because cubes and fourths are obviously a little bit harder to work with because you're writing that number out 3 times or 4 times. So it's a little bit harder to think about. I will say as well that if you have an even index, just like with the square root, you cannot have any negatives inside, but you could with a odd index. So for instance, the fourth root of negative 16 is not a real number because there is no number to the fourth power that would give you a negative. So we can't find a number. But the cubed root of negative 8 is actually negative 2 because negative 2 to the third power is negative 2 times negative 2 times negative 2, which is negative 8. So again, as you get higher up, it does get a little bit harder to think about. Negatives are okay for cubes because you can have that extra negative left over when you multiply. They're not okay for fourths because if you multiply something else 4 times, all the negatives would cancel. So like I said, this is kind of a little bit more advanced on where we're going. I really want to do a square root introduction to this video, but I do think it's important to note that there are other roots as well. So cube roots, fourth roots, fifth roots, etc., really do work the same way. It's the same kind of mental process, working backwards from that exponent. But again, they're a little bit harder to do because we don't probably have all of our cubes memorized or our fourths memorized, right? Whereas our squares, we're probably pretty comfortable with at this point.